So ephemeral containers, why these are needed? Okay, so we are going to look at these containers in this session, right? So we are going to understand the basics of container security, what is this container security and why this is needed, and what is the need for smaller Docker images, why we are so concerned about building smaller Docker images, and we'll see how to build smaller Docker images for Golang based applications using multi-stage builds. We'll see a normal build. At the same time, we'll also build the container using multi-stage builds, and we'll compare the both the containers images sizes, the one built with normal build and the one built with the multi-stage builds. And we'll understand what are Alpine images. Then we'll come to Distroless images. What is a and Distroless images? Okay, we already talked about them in the Docker session, but again, I wanted to repeat them. And finally, we'll understand what are ephemeral containers. Okay, why these are needed in case of Kubernetes. So basically, these are used in case of Kubernetes. Okay, and we'll understand how to debug pods with ephemeral containers. Okay. Basically, how do we debug pods? Like if something is not working as expected. So what are the commands
Uh,
we run in case of pods?
Log command. We can enable see kubectl log and then pod name.
Yeah. So we have one command. What is the other one? We can also
Events
describe the pod.
or describe.
Yeah.
Okay.
So one is okay. So there are three ways basically. So one is we use kubectl logs to see the logs of the pod, and also we can see the describe command. So under the describe event section, so we'll understand what exactly are happening. So if the pod is not scheduled, you can see that event there. If the pod is not able, the content image, if it is not able to pull from the registry, you can see that issue there, image pull error, okay, or image pull back off, correct? So those things, everything can be seen in the describe. And also we have kubectl events. So these will this command will basically show all the events in that namespace there.
So
From that output also you can see.
the events is like
Sorry.
it'll also show and describe, so same thing, right?
Correct, same thing, but describe shows for a single pod. So what is the describe command? Basically kubectl describe pod name of the pod, right?
Hmm.
But in case of events, we see the events in a namespace.
Also,
Let's say kubectl events hyphen and dev. So all the events in that namespace will be shown.
okay,
Okay, so it can be from all the pods.
okay.
Understood? Of course you can grep uh, from that kubectl events with your pod name. Okay, so that is also there. Understood? So why container security and what is container security? So nowadays we know that all the applications are being containerized. Okay, and at the same time containers are increasingly becoming popular because every application, like the monolithic application or it can be microservices based application, now runs under Kubernetes or any container orchestration engine. So these orchestration engines basically they run only container images. But at the same time, so all the security risks that that can potentially cause any businesses, okay, millions of dollars are also increasing, right? So basically why these security risks? Okay, so why using containers increases the security risks? Okay, so we'll understand. Okay, and containerization is one of the core DevOps process. We know this, right? So in the entire DevOps flow, so in one of the stages we containerize our application, right? When while containerizing any application, so we usually follow a lot of steps, right? Basically all the steps are mentioned in the Docker file. So one such instruction in the Docker file is from. So from indicates the base image. So if I am talking about Golang, so I can just say Golang latest. Okay, if it is Python, it can be Python latest. It can be any base image, right? So this base image, what all things it will have? Basically, it will have some system utilities and also some dependencies needed to build the application. Like for Golang, it will have Golang based. For Python, it will have Python based dependencies. Okay. At the same time, a container image can also have bugs and security vulnerabilities. Okay, so I'll show you what is the meaning of this. Okay, so security vulnerabilities in the sense opening up basically a port which is not intended to be opened, or else placing some utilities which gives others access to your container image. So let's say having bash or sh, so having both these in the container image, so anyone can go into the container and then they can read anything in that container, right? So simply anyone can do kubectl exec or docker exec and they can go into it. So these are all the unknown unwanted dependencies. Okay, so basically which gives a good opportunity for hackers to get access into the application running inside the container. Okay, so that application can be a production level application. So usually that application has a lot of data which could potentially cost business hundreds and millions of dollars in money. Hence, it is very crucial to scan and audit images regularly. So that means every container image should be scanned to see if there are any known vulnerabilities or any issues with that containers. Okay, so there are many container scanning tools available.
So,
So you can
quick
say
question.
Anchor Engine.
Just having
Yes.
a bash in a container allows you to run the exec command, right? Exec
Yeah.
ID.
So exec is not only to it is to run the command. So if you do kubectl exec and at the end if you put bash, a bash session will be open. But you can also have cat, ls, all those commands, right? If it is bash is not there, but still you can do cat and ls to see the contents, right? So all these are
Correct.
not necessary. Okay, having them, it's completely unnecessary. Anyone can go into your code and then they can see it. Okay,
Okay. Yeah.
so hence it is crucial to scan and audit images, okay, regularly. And so inside the DevOps process, generally we don't do it, but if you include security inside your DevOps flow, so that becomes DevSecOps, right? So DevSecOps plays an important role in adding the security part to your whole DevOps processes. Okay, like scanning your container images, or you can scan the images as well as the running containers also. It's both. So it is like static scanning and this is called dynamic scanning, where you are scanning the containers which are running, but here you are scanning the images which are not running as containers. Okay, understood, right? So when building Docker images, right, we are concerned about two things. Okay, first thing is the security. That means each and every image layer should be scanned. There should not be any known bugs or anything. That is the first one. So usually the choice of the base image can make the difference. And the second one is the size of the image. You should make sure that the size of the image should be as small as possible. You should not pack in unnecessary binaries, utilities, or dependencies. Okay, so we should try to reduce the size of the image without impacting the application running inside it. Usually by using multi-stage builds, Alpine images, Distroless images, we can do it. So we haven't talked about Distroless images. We'll talk today. Okay, understood. And then when it comes to container security, Distroless or minimal base images like Alpine can reduce the attack surface. The reason why Distroless and Alpine images can reduce the attack surface is usually they are very smaller in size. They only pack the needed dependencies, not everything. Okay, so we should not always use Golang latest or Maven latest. We should not do like that. Okay, we should see the minimal version of that image, like Golang Alpine or Distroless version of Golang. Similarly is the case with Maven also. Okay, so we should find such kind of an image. Understood? So why security scan is needed? The reason is so we not only put our image, the application inside the container, right? We also have a lot of other dependencies in the form of layers. So whatever is the Docker file instruction that you put, that can potentially be a source of a bug. Okay, unintentionally, you may download some library using run or anything, so that might download some unknown utilities or binaries which might be a bug. Okay, it can be anything. right? So scanning each and every layer is very crucial, because every layer that is inside the Docker image, so it will be from some instruction. Okay, so container security, basically what is container security? It is a process of identifying known vulnerabilities within the containers by using the scanning tools. So there are many scanning tools like Sync, Anchor Engine. There are plenty of them. So using if you run them, they'll show you all the vulnerabilities, and also the effect level, so whether they are critical, they are minimal. So that effect also you can show, you can see. Okay, so first thing is container scanning, so which we do. So next thing is smaller Docker images. So why smaller Docker images are needed? Okay, so container image should be as small as light as small and light as possible. Usually they should pack only your application code and all the runtime dependencies, not everything. Okay, so if you find any unknown binary or utility, you should remove it. Okay, or find an image with lesser binaries and utilities, but that smaller image should be able to run your application. Okay, and the
Is
smaller
that
this image is, the lesser is the attack surface.
is that usually where you save on space by cutting down extra utilities and bash commands,
Yeah,
etc.?
correct. So there are many uses. The first use is it is easy to pull the image from registry and also to push it to the registry. And let's say that you have three pods of your application. Okay, and one of the pod is killed due to some issue by the Kubernetes itself. Now, so the time between the third pod starts to come up and the actually it comes up, right? So that time, becomes critical. It should not be like that the third pod is just started to come up, but it took 5 minutes to fully come up, and the container application inside it is running now. It should not be like that, right? If the container image is small, so even the pod comes up so fast, right? Understood. So that's why you
Yes.
should have a smaller Docker image sizes also. There are many advantages. If it is smaller Docker images, they will pack only smaller to lesser to very minimal bugs. Okay, even the scanning of those images will be much faster. Okay, and we often we should always look for Alpine version of Golang images. Okay, so basically why Alpine images are smaller and lightweighted. Okay, as they have many files and programs removed. If I take the case of Golang latest or anything which is larger, like if you see the tags, so mostly latest tag will be some 330 MB or something like that. But if you go for Alpine version of the same Docker image, it will be much smaller, like 20 MB, 30 MB, like that. Okay, so both Golang latest and Golang Alpine both will run your application, but the utilities and dependencies which they are packing might differ. Okay, the same is true for node based images, Maven, Java. It can be anything like that. Okay, understood. So the same thing. So if it is small, Docker image is small, it becomes easy to pull and push your container image to the registry, and also they take less space. Okay, so that helps us in efficiently use the disk space and memory. Okay, if the container image is small, usually there will be lesser running processes inside it. Okay, we build the lessest smaller and cleaner Docker images. Okay, so basically we use Dockerfile to build the images, and once we follow best practices while writing the Dockerfile, we'll end up with writing generating smaller and cleaner Docker images. Okay, the some of the best practices, like you should not allow containers to run as root. Okay, root means giving him the admin privileges, right? You should not allow any of the processes inside that container with root privileges. Okay, and always avoid copying unnecessary files. Okay, if it is possible, use Docker ignore to ignore some files. Let just like your git ignore, Helm ignore, something like that. Okay, understood. And merge layers. So if you have multiple run instructions like run apt update or run apt install something. So if there are multiple run instructions like this, so always make sure that you only use one run statement to do all the updating and downloading all the packages. So the reason why is, so if you have only one run statement, only one image layer will be created. So that can in fact reduce the size of the image. And one thing is, we all know is try using Alpine or the Distroless as the base images, so they reduce the size. Okay, so in this demo I'm going to show you how to use Distroless images to reduce the size of the images, and how Distroless images can further enhance the security of your Docker image. And we all know that using multi-stage builds can reduce the size of your image, so I will talk about this in today's demo. And you should also have the health checks in place so that your container can be checked against whether the application running inside it is healthy or not. Okay, and try to avoid opening unnecessary ports. Okay, this is not at all needed. Only open the ports which are needed for your application to be accessible from outside, like port 80, 8080, like that. And you should never hard code the credentials. Okay, you should not hard code the credentials, because credentials are the secret information, right? You should always make sure that you supply it with, okay, using some objects like secrets, or using any third party softwares like Hashiko Vault or anything like that. Understood, guys? Okay, so how to choose the correct base image? And Docker Hub, we all know that there are more than 7 million repositories. Okay, there are a lot of images, and not all images are secure. Okay, some of them can be malicious, created by following some poor practices while creating the Docker images. Okay, so this could lead to the images with the vulnerabilities. And some images can be very old. Okay, so what developers will do, they'll create an image but they won't maintain it, right? So here I've used Anchor engine. Basically this will scan your container images. I've used Anchor CLI to scan the Python image. Okay, so here it is Python colon latest. Okay, now see what are the vulnerabilities it is packing. So there are so many critical ones. Okay, so we don't have to go through each and every uh, known bug. Okay, but see how many of them are critical and how many of them are high. So these are all there. So if your application is going to get affected with any of these binaries or the libraries, you should not go for this. So this is Python latest. The same if I use uh, with Python 3 Slim Buster. Okay, see this is the same Python, but this will occupy the much smaller size. Okay, this is a base image. If you scan this image, see there are no high or critical bugs when compared to the previous one. Okay,
Quick
so that's
question:
why it is always
these packages in the image, right? They are
images. Yeah,
added by out from outside when you build a Docker
yeah,
image.
correct. So when they made this image, so they might have used all these as the dependencies to run Python.
Because we never, when we are building an image, we never say, use this dependency or that dependency. That comes automatically, right?
Yeah, this comes automatically with the base image.
Okay.
Okay,
So I'm just trying to see that
we
how can one avoid using the ones which are critical, right? Severity. Because
yeah,
these
they should try to remove them.
okay.
Yeah, they should remove them or choose another base image, or entirely try to build yours.
Okay.
Okay, so now coming to the single and multi-stage build. So we follow multi-stage builds to further reduce the size of the image. Okay, so if this doesn't even reduce the size of the image, okay, we can do a lot of things, right? So we can remove unwanted binaries like npm bash. You can remove everything from the image. But still, if you don't see any change in the Docker image, then you can go for Alpine images or Distroless images. Okay, so what are Alpine images? So Alpine images are Alpine Linux based images. Okay, basically they are built. This Alpine Linux is also Linux distribution based around busybox. Again, busybox is a Linux. Alpine image itself is very smaller in size. It's just 5 MB in size, which makes it a great base image for almost all the applications. You can take Alpine and run some commands to install all the dependencies. Okay, so that's why if you take Alpine as the image and if you try to install Python or anything, so it creates some size, right, of the final image, right? So in order to avoid this, like taking Alpine and then installing Python, so what they will do is they'll directly give Python Alpine image. That means an Python Docker image based out of the Alpine Linux distribution. So usually these sizes will be lesser. Okay, so by using Alpine Linux as the base image and adding only the required dependencies and your final artifact or the binary or anything, which is basically your application, results in a smaller and cleaner Docker image. Okay, now see the a small difference. The first one is Maven based, uh, application. Basically, it's a Java based application built with Maven build tool. Okay, if I take Maven 3.6 with JDK 8 as the image, and here I try to copy the source code and then run mvn clean package to package my jar file. Okay, so the entire container image, if I use this as a Docker file, see the size went up to 594 MB. So of course, this is a single stage. I can go with multi-stage also. Okay, the same thing if you take in case of Maven, same 3.6 with same JDK 8 Alpine version, right? And the same instructions. The rest of the instructions are same. See the size now, the drastic reduce in the size from 600 to 200, right? Understood. It's greater than 60% reduction in the size.
Correct.
Understood. That's why you should always try to find images with Alpine. Okay, understood, guys. Now coming to the
Yes, yes.
Distroless images. So we said that having Alpine images will reduce the size of the image. Then what are these Distroless images? Okay, so these Distroless images were introduced by Google to improve the security and the container images. Okay, security of the container images. So these are just like your Alpine images. Okay, but these will not have any operating system distributions or any utilities. The meaning is these Distroless images will only contain your application and its runtime dependencies. Okay, and any package managers, Linux shells, or any programs which we generally see in other images are completely removed from Distroless. You will not see even shell, bash, or even curl. Okay, package managers like apt-yum, you will not find anything. Even at least Alpine images might have sh, even that sh is not available with the Distroless image. Okay, these storage images are very smaller in size. It will not have anything other than your application and any runtime dependencies. Okay, understood. And Google has released distroless images for almost all the programming languages like Java, Maven, Python, Golang. They have distroless images. Okay, so in order to see these distroless images, right, so you can just search for Google distroless images. Okay, so this is a repository, right? So the same thing, what are distroless images, and why should I use distroless images? Restricting what's in your runtime container to precisely what is necessary for your app is the best practice. Okay, and distroless images are very small. The smallest distroless image, okay, which is this, okay, static debian 11 is just around 2 MB, and that too we have Alpine image which is 5 MB, right? So this Distroless image is even lesser than your Alpine image. Alpine image, if it is 5, this is even 2. But you can ask me a question, what is the use of this 2 MB image? Simply you have a binary file. Okay, that binary file doesn't need any dependencies. Then simply you take this and run your binary inside it. That's it. Okay, so here if you check the okay, Distroless images, so we have for Java, okay, Node.js, and you can also find the images from here. See also here they have given example for Golang based. Okay, so for multi-stage builds, right? So first what we'll do, so we'll generate our final application here in the first stage. Basically this is a binary file here. Okay, that binary file can be executed in any image. It doesn't need Golang image only to execute. That's why we take that binary from here and we copy into the other stage. So that other stage can be simply your Ubuntu, CentOS, or it can be Alpine. But Alpine means again it's 5 MB. But if you take the base Debian 11 as the base image, okay, so your app will be fully secured. Okay, see if I take from, and if I take very small image like Alpine, that Alpine image will have sh. But if I take this Distroless image, so what I'm doing, I'm just putting only my final application. That's it. It will be very smaller in size. Even for Python 3, if you click on this, see they gave an example how to use Python Distroless image to further reduce the size and also make your image secure. Okay,
So in enterprise,
understood, yes.
they
So there are,
use Distroless mostly in enterprise.
yeah, they use Distroless mostly,
Okay.
or else Distroless images can be put inside the production so that no one can use it. But so far I'm saying about Distroless images, but what exactly is the use with this Distroless image? Okay, so before seeing a small demo, let's see this screenshot. So here I'm using node 8 as the image. Okay, I created a container based out of node 8 image, and then I use docker exec -it. The name of the the name of the container is node, and the bash process I've started. Okay, then see the bash has now started. Correct.
Yeah.
Take the same with GCR Distroless node.js image. Okay, then try to get into bash. So it is saying bash executable file not found. Same you try with sh is not found, right? That means no one can enter that image. So if you want, you can also see if you can do cat on something or do ls mkdir. Just see if any of these binaries are there or not. Okay, so for this demo I have a Golang based application. Okay, so I'll share these files. I have this Golang based application. Okay, so here this is my main file. So in this main file I've used a lot of the few endpoints I've created. The endpoints is slash health and slash details. If it is slash, so basically I'll get this response application is up and running. If it is slash health, I'm going to get this response JSON response that status is up and the current timestamp is written. If it is health sorry details, so I'm going to get the host name and IP of the container written. This is a simple Golang based application. Okay, so I have this Docker file created. Okay, so first what I'll do is I will not use the Distress image. Okay, so basically I'll use a normal image where Golang latest is the base image. Okay, if you want you can just remove as builder, that is completely fine. Okay, or
Yeah.
even if you put it's fine because it is a single stage. Okay, it will not create an issue, otherwise you just remove it. Okay, bug dir slash app. Okay, so basically this go.mod file will have the dependencies. So here I need this Gorilla Mux and this is the version as a dependency, and this sum file basically it will log the dependencies at a point of time so that I'll get the precise dependencies. So first inside the Docker file I'm just copying my go.mod and sum files, because I would run go mod download just to download the dependencies first. Okay, if you see in case of maven, right? So first what I'll do, I'll just only copy a pom.xml file if I need, and then I will just run maven. Which one? Hmm? Compile, right? Or maven install anything. So first my dependencies will be downloaded. So similarly,
It was three, right?
after that,
Compile, deploy, and
sorry,
install.
yeah, install and deploy, correct. Okay, so now I'm copying the rest of my code, dot and dot. So that means take everything from basically the current location. So the current location, if you see, I have this main.go sum and mod. Okay, Docker file and Kubernetes. These are the manifest files. Go app. This is a Helm chart. These are all not needed for me while building the application. Okay, but copy dot and dot will copy everything. So that's why I have Docker ignore. Inside the Docker ignore, what I can say, I can just say don't copy go app because it is not needed to be sent to the daemon for building the image. At the same time, don't copy Kubernetes folder. This is also not needed. Okay. At the same time, don't copy. That's it, right? Nothing is there. Okay. Understood. So this is a single build. So I'm using go build as the command to build the application, and hyphen o is the output name. So main is the name of the exe file that will be created. It's a binary file, and dot means put that binary file in the same. So I'm exposing 80 because my application runs on 80, and as an entry point because main is the exe file. So what I have to run it, right? How do I run it? Simply in Windows you can do main.exe, right? You can also double click on that exe file, but in case of your Linux it should be dot slash that main. So if it is bin, you just use dot bin, something like that. Okay, so this is a single stage build. Okay, let's see basically how to um, build this image. Okay, so I have uh, I'll create one Minikube cluster. Okay, so what I have to do, I have to use Minikube start.
What's the Go mod download? What is that?
So go mod download is basically it will look for a file called go.mod. Okay, and download all the dependencies which are mentioned in this file. Okay,
Okay.
here there is one dependency, right? So
Uh-huh.
if you have a lot of dependencies, then you'll have require like that. Then this go mod download means read mod file go.mod and download the dependencies.
Okay. And the Go mod sum.
Go mod sum is like so these dependencies will keep changing, right? So you want
Uh-huh.
the dependency that was committed with a commit hash. Okay, so that means I wanted to take that the dependency which is committed exactly with this sha. Okay, these are generated if you don't want your dependencies to change in the later point of time.
Okay.
Okay, so this is like exact or precise versioning. Okay. Okay, so now my Kubernetes is up and running. So basically I wanted to build the container image, but the reason why I created the Minikube cluster is inside Minikube Docker is running. We all know that, right? So I'll switch
Yes.
to git bash profile, or you can also use any terminal which supports your Linux commands in Windows. Okay, so if I just do Minikube status, okay, I have everything running, and if I have to connect to the Docker daemon which is running inside the Minikube, okay, if I just do Docker ps, it won't detect because there is no running daemon within my machine. It is running within Minikube. So Minikube basically exposes certain environment variables. So if I just do Minikube Docker env, is going to give out all the environment variables that are necessary for me to talk to a daemon. So inside this daemon, minikube daemon is running in this address. Okay, so if you want, I can copy all the first four commands, and then I can paste it so I can talk to the daemon, or else simply do eval dollar, okay, and this total command. So this is going to evaluate the or run the complete output of the statement. Okay, done. So now if I do docker ps, so now I'm able to connect to the daemon, right? Understood, guys? Okay, so if I do ls-l, so inside the go microservices, so I have this docker file, right? So this is a full file, so let me build it. So docker build hyphen t, tagging I'm just saying go microservices, like it's a normal build, it is not multi-stage. Go ms normal. Okay, or else what I can do is, so I can simply tag it with my own name because I wanted to push it. So my user account of the docker hub, oms normal. Okay, or else you can just say go ms, the tag as normal, let's say. Okay, anything. Okay, I have to put dot. It is downloading all the dependencies and it will build the my container image. So if I do docker image ls, and if you check the uh, my go ms normal tag is normal, see it is 972 MB. It is so huge, right? It's not small. Okay, so first let's try to run it. So it is docker run hyphen d, name I'm going to use as web, image name we all know, this is this go microservices, the tag is tag, internally it runs on 80, so externally also I'm putting as 80. Okay, so this port mapping should be before, right? 8080. Okay, so it is saying the name web is already there. Okay, so let me remove that web content which is already there and try to run it. Okay, so it is running. So if I do docker ps, so there would be a container with this image. Okay, so usually dot slash main is the default command, so it is running, so I can access it. Since it is my minikube cluster, I'll use minikube. Okay, if it is your any cluster, you should take that cluster ip. Okay, so this is my ip of minikube. So I'll go to the browser and then just, if it you can enter 80 if you want, or else you can leave it. So this is the first endpoint. So I also have something known as slash health. So this would basically return this status, whether it is up or down, and some timestamp. So every time when you refresh, the timestamp changes. I have one with details. It is going to give the container host name and the ip. Okay,
Is this is this defined
but
in
what is the disadvantage? Yeah,
the
it is
health?
defined. So if I go to the source code, yeah, if I show you the source code, okay, see health handler, it is running status and it will give the current timestamp. So every time when I hit that url on slash health, the current timestamp is fetched
Okay.
in the real time. Similarly, host name is fixed, ip is fixed, so I cannot do anything about it. Okay, but what is the problem? The problem is my container image size is 972. Okay, so let's reduce it. So I know that in this stage, main is my exe file or the binary. So let's uncomment these. So I'll take this binary file from this stage and I'll copy into the next stage. Okay, so if you see the Distroless image for Golang, they already gave this part, right? This Distroless base Debian 11, the same I'm using. So I'm taking this as a base image. Okay, and I'm copying from the previous stage. The previous stage is named as builder, so I'm naming it as builder. Okay. From builder, where is my main file? It is slash app slash main. So from slash app slash main, I'm putting dot, that means current working directory. That's it. So have expose here and my cmd here. That's it. So here, instead of running my cmd here, I'm running in this image. Okay. Now let's try to build. This is a multi-stage build. Okay. So let's build this image instead of normal. Okay. Let's say this is Distroless. Okay. Okay. So
I mean, isn't
what did
Golang
he say?
Linux and GCR are they not going to have the same stuff in there?
GCRIO Distroless base DBN. Sorry,
Yes,
I
but
didn't
like
get the question.
both have the Golang base, right?
Huh?
So I mean, is it not redundant? The second one,
No,
the
no.
second.
Actually, this is Golang based. This is not Go based. This is
Oh,
simple image without any dependency. This is just an Debian image.
because this is
It
the
doesn't
OS.
have any Go.
It's just the OS
It is
image.
just a normal base OS. Correct. It will not have anything.
Okay.
Okay. It is saying invalid from flag value builder get mm, from builder. Okay, sorry, it is a typo. It's builder. Okay, so now it is created. This time let's do Docker images again. Then see what is the size of this Distroless. See the Distroless. See, see the difference between a 972 image and a 27 image. Almost we saved 950 MB of size. But there is one question. So will this image or the application run as expected when compared to the same normal image? Let's do that. Let's create an image, sorry, container based out of this Distroless image. Okay. Oh,
There's
one
an
second.
Mr. T.
It is running. So if I do Docker PS, at the top you should see it. Okay. Now let's go to the browser and see. Okay. See here, it is now running. Slash health also it will work. Right? It is working.
Yeah.
Understood. Slash also will work. So there is no difference. So only thing is we changed the, we saved almost 95% of size. But what if I want to so if you see the previous container, okay, which is based on the normal build, so inside it you can go into that container. That means bash will be available, sh will be available. Now see whether we can go into that web container which is created out of the Distroless image. Okay, docker -it, name of the container as web. Let's see bash. See, bash is not there. Let's see sh is not there. Let's see any other command. Curl some local host. Curl is not there. Let's see ping. It is also not there. Let's see ls. Ls, my root directory. Ls is not there. Let's say mkdir/tmp. That is also not there. Right? Even you can just cat maybe slash main, which is my main file. See, cat is also not there. Right? There is nothing in this. But still my application is running because the only needed dependencies which are needed are available. Any questions, guys? Okay, understood. So let me push both the images, okay, so that I can pull it. So now we understood what are the advantages of the normal, okay, and the Distroless. So basically I don't need this normal, I need Distroless to work with my next example. Okay, let it push. Okay, now let's see what are ephemeral containers. Okay, so far you understood that having Distroless images will reduce the size of the images, but for debugging it becomes very difficult, right? You cannot debug that container.
Is
Understood?
it because you're
Because you will
not
not
able
have any
to,
debugging utilities.
but you can still see the health
Sorry.
check, but that doesn't help in telling you where the error is probably, right?
Yeah, correct. So if it is yeah, correct, it is running, so you are able to see the health. If it is not running, you cannot debug it, right? By going into it or by running some commands inside that container, you cannot do anything, right?
Yes. Okay.
Now how do you do that? Okay, so with ephemeral containers basically you can do it. Introduced in Kubernetes 1.16 as an alpha feature, but now it is in the beta state. Okay, so what does this ephemeral container will do is it will add one more container to an existing pod. Okay, so if I take this example, okay, so I have an application container, so this whole thing is a pod, and I have only one container which is my application container based out of Distroless image. So this can be Golang, it can be anything, but it is Distroless, so it will not have bash, sh, curl or anything to debug. But inside this pod I only have one container. Then how do I debug? It is through ephemeral containers. So if I create an ephemeral container, okay, so this ephemeral container sits within the same pod where your application container is running. So it is like having two containers in that pod. What is the advantage of using ephemeral container? These ephemeral container can be anything. Okay, so that image or container should have debugging utilities like bash, sh, curl. So whatever are the debugging utilities that you need, so you just simply put it in a image, then you create a container out of that image, that becomes your ephemeral container. But the only thing is it will not run in a separate pod. Instead that ephemeral container will get placed inside an existing pod. Okay, understood guys?
Yep.
Can you come again,
Okay,
Vikram?
so now this so here this is a pod. Okay, this pod has only one container. Okay, your application container, main app container, this is Distroless based. So this Distroless based container will not have any debugging utilities, right? Understood? So if this pod is
Correct.
failing and you cannot debug it because kubectl exe itself will not work, then you create one ephemeral container. So this container will have all the debugging utilities which you need. Okay, like bash, sh, curl. Understood? Now since these are in the same container, same pod, right? Basically, so they can talk to each other, right? That means I can curl this application container using curl or ping. It can be anything. One more advantage is, with this is, so this debugging container will share the process space with the this application container. That means whatever are the processes running inside this application container are visible to this ephemeral container, which I am going to prove. Okay, so you can see the
Yeah.
processes running inside it, you can restart the processes, you can do anything inside this application container because
Now,
we have an ephemeral container.
yeah. But these are in
Sorry.
a pod, right? Like, is this different from if there's like
Yeah, pod.
applications running in the same VPC, then they don't share this stuff, right? It's only
Yeah,
in a pod. In a pod, they share everything because it's
in
network.
the
But in the
pod they are sharing. That is the
okay,
yeah, that is the advantage of this basically your ephemeral container. It shares the process space with the application content so that debugging becomes easier. So otherwise you will not be able to debug at all.
okay.
Okay,
Basically,
that's the
one
advantage.
container for the whole pod, and you can have so many different distroless ones, and they can all share the same ephemeral container, right?
Yeah, but ephemeral container usually, yeah, correct. So it can see all the processes.
Okay.
Okay, so you can debug conditions such as crash loop back off also. Okay, so in this case also you can use ephemeral containers to further debug the state. Okay, understood case. So where debugging becomes easier, you can use ephemeral containers. And not all ephemeral containers, not all clusters are supported, support these ephemeral containers. Okay, for some clusters you have to explicitly say to allow ephemeral containers. Okay, because this is in beta state. And also these ephemeral containers have no resources scheduling guarantee. They will not be restarted. So once these fail due to some issue, okay, so they will not restart. So either you restart the pod to restart them. Okay, so having an ephemeral container, so let's say this is the pod with one container app. This pod has given some 1 vcpu and some zero point 0.1 m memory or something. So if you put one ephemeral container in if it is increasing your cpu and memory restrictions, right? So the pod gets automatically killed by the kubernetes in many cases. Okay, so if your ephemeral container makes your complete pod to reach or to exceed certain resources, so this pod might be deleted by kubernetes. So that's why you should be very careful. So it's not like that placing one more pod gives you more resources to your existing pod. It's not like if your ephemeral container causes a pod to exceed its resource allocation, the pod may be evicted. That means it can be deleted. And also, so we have the YAML file, right? Manifest file, where we use API version, kind, metadata, spec. Okay, so directly your ephemeral content you cannot mention in the spec or any of your YAML files. Okay, so you have a specific command using using which you can add those containers into an existing pod. Okay, you cannot put it in the pod spec. Understood, guys? And for Minikube, right? So for every cluster, okay, you should enable certain options to allow ephemeral containers. Similarly, for your Minikube, so you have to start Minikube with this option that allow ephemeral containers. So if you want to know more about this, you can go to this link. So where they'll tell you how to enable ephemeral containers in the Minikube. Okay, for just what we'll do is, for now, we'll just stop our Minikube cluster and restart. Basically, I have what yeah, Minikube start with feature gates that allows the ephemeral container. So I'm enabling the ephemeral container. So let it restart. Okay, so let's go to the ephemeral container page and understand more about the usage. So this is the ephemeral containers. Okay. So pods are fundamental building blocks of Kubernetes. Since pods are intended to be replaceable, you cannot add a container to the pods once it is created. We all know this, right? So last time also we seen this. So once you have a container running in a pod, you cannot add any extra container. Either you delete that pod, add an extra container in the manifest file, and you recreate the pod. You cannot simply use kubectl edit and try adding one more container. You cannot do it. Okay. Sometimes it is necessary to inspect the state of an existing pod. However, for example, to troubleshoot a hard to reproduce bug, okay, in these cases you can run ephemeral containers in an existing pod. Okay, if it becomes difficult to debug your pod, then you can create another container in that pod through ephemeral containers. Okay, ephemeral containers differ from another containers. Okay, in that they lack the guarantees for resources and execution. They will never be automatically restarted just like your normal containers. And ephemeral containers are described using the same. Okay, so this you leave. Okay, they cannot have any ports. So the ephemeral containers are like they have only utilities such as bash sh like that. They cannot have any not run any applications, web applications. So that means they cannot have this readiness, liveness, ports. These are all for web applications, right? But what are ephemeral containers? These are just debugging utilities. Why they will run an application themselves? Correct? Understood, guys? Now go to the next link. Here, they gave all the what do you say? The commands how to. Let's first understand how to why to use these ephemeral containers. Okay, so here I have. So here it is saying my virtual box is giving an error. Let's do one thing. Let's stop this Minikube. Sometimes this issue comes, so I'll simply close my virtual box. Okay, now let's start it with feature gates ephemeral containers enabled equal to true. Okay, so it is restarted. Okay, so let's see first how to run my image, right? So I'm running a web, and the image I would be using is my full image, let's say kunchalavikram slash go hyphen port I'm exposing as 80. A web is created. So if I get kubectl, if I do kubectl get pod, so it is saying web, it is running state. Okay, 9 seconds ago. Now in order to debug this, so I can use kubectl logs hyphen f and the name of the container it is web. So to see the server has started. Okay, and if I expose it outside through service, I can also see some log. But since I didn't say anything, I'm not going for that. Let's see if I can exec into this pod. Kubectl exec it, name of the pod is web, double space to separate the kubectl command and the other commands. I'm going into bash. The bash is there, right? Since my application is running on port 80 internally, let's see if curl is there or not. See, curl is there. So curl, I can just do localhost. See, debugging is becoming easier for me. I'm able to see. And let's see if I can do slash health on that localhost. See, I'm getting right. And also I can see the other endpoint details. So that means I can still debug my application using exec by going into the container. Correct, guys?
Yes.
Right? I'm
Yeah.
deleting that pod. Now see if I do the same with my Distroless created. Let's see get pod. It is in the running state. Now if I try to exec, so whether I'll be able to do or not. See, I'm not able to do. I'm not able to do sh also. I can't even do curl localhost. That means debugging becomes easier. Sorry, difficult for me, right? Understood. So in this case, what I'll do, I'll add an ephemeral container. Now let's see from the documentation how to use the ephemeral container. Okay, so debugging with logs we can do. We can debug with container exec, but unfortunately with Distroless we will not have it. Now the third one, debug with ephemeral debug container. So in order to do this, what we'll do, so basically first we'll run our own container. Okay, so the container they are using is this pos 3.1. So our Distroless image and this pos 3.1, so they are mostly like same, because this pos 3.1, even this doesn't have any utilities, just like our Distroless image. So either you use this or you can use mine. So for timing, what I'll do, I'll use my own image. Okay, so I'm running an ephemeral container. Okay, so image I wanted to use this instead of that pause, same thing. And they gave restart is equal to never, because I don't want to restart this pod if the container inside it fails, or I don't want the container to restart. Okay, um sorry, I have to use the hyphen tag here. if I just do kubectl get pod, so I have this this pod running. Okay, so in fact this is our Golang application only, right? So that means if I just do kubectl exec hyphen it and this name of the pod and hyphen hyphen bash, still I won't be able to run anything, right? Because it is running the same image. Only thing is the pod name has changed. Understood, guys? Right? So how do I debug it? So how do I debug it, guys? By using ephemeral container. So here they have various options. Okay. So here if they try to exec into this pod, it will say runtime error. That means you can see the error at the end. Executable not found. So here sh executable not found. If you use bash, it will say bash is not found. Okay. Now see what command I can run. Here I'm running kubectl debug. Kubectl debug will create a ephemeral container. Understood? Understood, guys? Any questions? This is the command.
So
Kubectl debug.
we can't say kubectl run ephemeral container, but we can say kubectl debug ephemeral container.
Yes, exactly. Yeah, because here kubectl debug hyphen it. Here we have to give the pod name into which you are creating an ephemeral container. If you see running, I gave this pod name. This is your normal container or normal pod. So I have to give that.
So this is basically a container in a container.
No, this is the pod. This is the pod name. When I'm running kubectl debug, I should give the pod name.
Okay.
Okay,
But usually
and
it
which
for everything else we want to do kubectl run XYZ.
yeah,
But for
correct.
ephemeral one, we want to say kubectl debug ephemeral.
Yeah, because it is not a container in itself. It is not a pod. It's like a container that runs alongside with another container.
Okay. And then it always has to follow with which container you want to run the debug ephemeral with, right? So this one is busybox, like for
Exactly.
example.
In which pod you wanted to run?
Okay.
Yeah, in which pod? So I wanted to run in this pod, this
Yeah.
container image, and
Okay.
target is also same pod name.
Okay.
Okay, I can directly run this. Okay, so here this will be okay. So basically, this will download the busybox image, and then automatically it will create that particular container inside that. Okay, and also what we doing here, we did it in the interactive mode. That means this particular container opens in the interactive mode. Okay, now still if you are not clear, let's do one thing. So let's see kubectl get pod. Now see the how many containers are running in this. Okay, which one is this? This is ephemeral. Okay, let me do ls-l. Okay, and then uh, let's do pxaux. Okay, so this is not okay, ephemeral container. Yeah, so we already have this up and running. Okay, so now what I did, basically I ran the busybox, right? Inside this busybox, it has opened the terminal, right? And when I check the psaux, why I have the slash main as the root process? So inside the busybox, did I copy that main file? So where is this main file? It is in my basically here, right? Slash main. It is in my Distroless image. Why busybox container image is here? Slash main is here because, as I said, everything shares the same process space, right?
Yeah.
Understood, guys? So the process which I am querying is from the busybox, but it is the slash main is from the another container, right? And if I have curl, so curl is not found here. Okay, so I'll show you how to curl that. Here I'm able to debug the process, right? Because I can see should container, I can see the other processes also. So for this in the text document also I gave this. Okay, so this time let me show you one more example. Okay, so here let's delete all the pods. Okay, so there is another case. In the earlier case, a container inside the existing pod. Let's see another example. Okay, so debugging pod using a copy of the pod. In this case, what happens is you'll have a pod. Okay, so basically, so you'll have a pod. So inside the pod, a container is running. Okay, in the earlier example, we created one more container within the same pod. But in next demo, what we'll do is we'll have a pod running, which is an ephemeral container inside it. In order to debug this, what we'll do is we'll create one more pod with an existing ephemeral container and sorry, with an existing application and one ephemeral container. Okay, instead of debugging in the existing pod, we create a mirror copy of the pod and then we'll insert the ephemeral container there. Understood?
But that's what we're doing now, right?
No, in the earlier case, we are doing it internally.
Because we just said kubectl debug ephemeral, and then we gave the pod
Debug.
name.
Yeah.
Then we gave the pod name, right? So that
Yeah. Correct.
it's in the same pod. So that's what,
Correct.
right?
Yeah.
Okay.
Now copy of the pod and then we'll create an ephemeral. Okay. So for this, they gave some busybox container. Okay. So here in this busybox container, what they're doing, they're sleeping for 1 day. And then here they're creating a debug pod, my app -it image Ubuntu they are creating, and also they are saying share processes and copy to my app debug. So it is like it will create one more pod and then it will copy it. Okay, so in order to clear out the confusion, what I'll do is, so I have the same cube still run my app image. I've changed it to my own name. Okay, so here it will be Distroless. Okay, whatever is the name that you have used, go ms. Okay, port 80, a restart is equal to never. So this command I know, so this will simply create my uh, a pod with one image, one container, right? If I do kubectl get pod, I can see it is running. Now I wanted to debug that pod by creating a mirror of that pod or copy of that pod. Simply run the next one. So for this, what I did is I created my own curl image. Okay, so in the example they are using Ubuntu, but here I'm creating my own one called curl pod. Okay, why curl is needed is because this is a microservice. Using curl I can debug this one, but this curl is not existing here, right, in the first image, because that is a Distroless image. Understood? So I'm creating one more container with basically with curl so that I can curl that image. Understood, guys? So let me run the next one. And in order to know how did I create that curl, this is the Docker file. Okay, simply I took Alpine as the base image and then run apk add curl. So this will give you a curl inside that Alpine image. Understood, guys? So I gave that also. So this time what I'm running a curl pod which I'm, I already placed inside the Docker hub, so you can see. So let's go to the next tab and do get pod. See here, I have main container running, main application running, and see my debug pod. Okay,
Great.
what it is doing, it created this already existing pod and then it has placed my debugging container inside it. Yeah, so now it is 2 by 2, it is running. Okay, see here, it created that process, right. So where are we? We are in this pod. Basically this pod has the debugging container which we call it as a curl image, and this one. So if you're still not sure, what you can do, you can just do kubectl describe pod, and name of the pod is my app-debug. So you'll have two containers. So one is my app and the other one is the debug. It is a debugger image, this curl image. Understood, guys? So that means they both share the same process. That means if I just do px aux, I can see the processes running inside that normal container, which is this my app container, right? My app. That
Yep,
means
correct.
the slash one. Okay. So if I have to curl localhost, see, I'm able to get the output, right? That means I'm able to talk to that Distroless container, even though I don't have the curl, because that curl is being provided by the ephemeral container. I can do curl help. See, I'm able to debug that, right? Right, guys?
Yes. Yeah.
So using ephemeral containers, it makes it easy if you don't have any debugging utilities in your Distroless images. They both share the same process namespace so that I can easily work with it. Okay, so there are other examples you can try. Okay, so that's mainly about the ephemeral containers.